Question 40. The midpoints of the sides of the outer square shown below are the vertices of the inner triangle. So these points here. Thus, the outer square is divided into 5 regions, the inner square and 4 right triangles. What is the ratio of the area of the inner square to the total area of the 4 right triangles? Okay, so we're looking to compare the inner square to the combined area of these triangles. So ratios are always part to part, and it's easier when they're broken up all into the same number of, or to the same size parts, right? So what's tricky here is that you've got this inner square that is a different size and shape of all of the triangles. But we can break this up into parts that look like our triangles. So now we have our triangles and our square all broken up into this size and shape part, right? So they're all in equal parts. And if we look at our inner triangle, the inner square, it's made up of 4 of them. So 4 of those parts. And then the triangles, well, there are 4 of these as well. So this gives a 1-to-1 ratio. And again, you can always just eyeball it as well. There's no other way that you can draw a square that has an inner square whose vertices are the midpoints of it. So, I mean, it looks like 1-to-1, right? If you were to, you could also like fold each of these triangles inside, and it would cover the area of that inner square exactly, right? So it's the same area for both that inner square and the outer triangles created, just if you're able to visualize that as well. However you get there, it's 1-to-1, so break it up into even parts and see how many parts of the one portion there are to parts of the other portion.